concepts of lean construction. And he continued this work into his PhD and extended it ever more to look at very novel areas, including transformation, flow, and value. Musab was a top student at Birzeit University, where he did his undergraduate degree. And it's my great pleasure to introduce him right now for his PhD seminar. So Musab.
Yeah, thanks very much, Sabina, for this nice introduction. So
I will
actually,
mute myself.
yeah,
Great.
yeah. Then thanks, Sabina, for this very nice introduction. Actually, today I will give my seminar lecture, which is entitled as a process-oriented approach for green building performance evaluation based on lean construction and building information modeling. So the contents of this lecture is to talk about introduction, problem statement, knowledge gap, research questions, aim and objectives, methods, and to show work done, conclusion, and the contribution of the research. So, construction industry is a critical prerequisite of economic growth and well-being in every country due to the creation of projects, of infrastructures, of employment opportunities, and improving the whole lifestyle. However, in 2022, the construction industry exceeds $11 trillion, which show the importance of the construction industry contribution to the total GDP. While in the other hand, no one can ignore the effect of the construction environment on the industry and the amount of energy consumed and the amount of greenhouse gas emissions generated. Like according to the International Energy Agency, the construction industry is responsible for around 36% of global energy consumption and 39% of greenhouse gas emissions. In the last 3 decades, most efforts of the construction industry to improve the environmental performance of construction industry focus on adapting and implementing green building rating systems like LEED, PREAM, CASB. So although these green building rating systems aim to improve the construction industry, but actually they are more focusing on the operational phase of the building, while the construction phase, it did not take some into consideration, which ignores the impact of the construction phase. Although there are a lot of construction technologies, management approaches that implication should reduce material and different kind of process waste, but these efforts until now, it's not categorized as a standardized things to taken into consideration while making assessment for green building rate for green buildings. So for example, lean construction, which defined as a way to design the production system to minimize waste of material, time, efforts, and maximize value, and it contributes to reduce different type of waste, is not considered, for example, in improving the environmental performance for buildings. So what is waste in construction? Waste is one of the central concepts that lean aims to eliminate. It represents any exhaustion of time, money, and resources that does not bring direct value to the customer. So Bolfkin defined or categorized 3 types of waste: waste related to transformation or physical waste or material waste, waste related to flow, which is time loss, and waste related to value, which is value loss. So material waste or material loss could be material waste, non-optimal use of material, or non-optimal use of machinery, energy, or labor. While time loss, it could be in 2 things, in the product flow or in the work flow. In the work flow, like unnecessary movement of people, unnecessary work, inefficient work, and waiting. While in the product flow, it could be space not being worked in, material not being processed, or unnecessary transportation of material. Value waste can be take 2 things, in the main product and in the byproduct. In the main product, lack of equality or lack of intended use, while in the byproduct, harmful emissions and injuries and work-related sickness. So, in construction industry, production in construction can be understood in three complementary ways. Transformation performed by workers, equipment, tools, flow, which include product flow and process flow, and value, which is the customer's ultimate goal. In the current state of construction industry, construction is associated with numerous amounts of wastes. Some of these wastes are tangible and visible, like material wastes delivered to the landfill. However, there are many hidden wastes represented by process waste and their associated operational waste. So, green building rating systems focus on improving the environmental performance of buildings, ideally on a life cycle basis relative to conventional buildings. They focused on materials used in construction, methods of planning, methods of recycling water, building efficiency in lighting, insulation, acoustic performance. However, the approach is tailored to meeting end product requirements. While these requirements are influenced by many construction processes and their associated operation. So improving construction process can improve environmental performance since it will reduce the impact in both the final product and the whole supply chain process. So if we look on this figure, actually this is a flow line chart I created from a real data from a construction project. Y-axis represent the Y floors, while X-axis represent the project duration. And those lines represent the different trades or work in the construction site. Like, for example, here, the main structural system, the partitions, electrical. So if one of us look on this figure and need to highlight the environmental impact for the construction industry, generally we look on the embodied greenhouse gas emissions in the material, like in the concrete, in the tile, in the blocks, or embodied greenhouse gas emissions in the material waste, in the waste resulted from the different activities. While we generally don't look on the space waiting, for example, after one contractor finished the work in a specific location and the successor one will start. Or we don't look on the operational waiting, like after a subcontractor finished working in a specific location and waiting until start working in the next location. While these types of waiting, which is defined as waste, has its own embodied greenhouse gas emissions, which is ignored in the current state.
Musab, what is the unit of analysis on the x-axis? It's days?
Yeah.
Okay.
So researchers focus on green building rating systems from a transformational perspective. They focus on the embodied carbon emissions in the product and the transportation of the product from the source to the project. However, they neglect the process and their associated operations. So they miss the impacts of wastes related to the flow and value aspects. So this research generates many questions. The first one, are the current green building rating systems adequate? In what way are the current green building rating systems inadequate in terms of reducing environmental impact? What is the effect of applying a transformation view approach alone to achieve green buildings while ignoring flow and value views? What are the differences in emissions resulting from different flows in alternative operations? What is the effect of the project overrun or the effect of the project duration from environmental point of view? What are the best ways to overcome the gaps in the current green building rating systems and to include the flow and value perspectives? What data are needed to complete a comprehensive environmental evaluation for the construction process, and how can we collect the required data? So this research aims to explore the effects of construction industry on reducing and improving greenhouse gas emissions during the construction phase, to develop a framework that measure embodied greenhouse gas emissions stemming from construction activity based on the transformation flow and value theory. Introduced knowledge about the process effects of lean construction to optimize green buildings. Develop a method to measure the environmental effects of different construction production systems, and identify the effect of different management approaches in reducing product and process waste and improving the overall environmental performance for the construction industry. So, in this research, I used multiple research methods in order to answer the proposed questions. At the beginning, I conducted a systematic literature review, which covered 5 different subjects related to green building rating systems, waste in construction, lean construction, building information modeling, and life cycle assessment in order to understand the interactions between these 5 disciplines and their importance in reducing greenhouse gas emissions, and to highlight the missing in the current state. In addition, I used several case studies, and I selected case study research methods because actually it's widely used in management science, and each case study has its unique features. So it can give us an insight to understand the behavior of construction industry. In addition, I used life cycle assessment following ISO 14040 methods to calculate the reduction in greenhouse gas emissions, and analysis of data from large construction dataset that applied greenhouse gas emissions protocol. This helped us in identifying how the effect of project duration on greenhouse gas emissions, and help us in developing a method and an index that can help any client to capture greenhouse gas emissions during the construction phase. So in this research, I mainly executed 5 experiments. The first 2 cover the transformational part, while other 3 are covering flow aspects. Now I will talk on these experiments in details. Actually, in the first 2 experiments, which are talking about transformation, in this lecture, I will talk about experiment number 2 because the results was more visible to explore here and due to the time limitation. So let me start for the experiment number 1, reducing construction and demolition waste through lean production. So in this experiment, I tried to evaluate the reduction in construction waste due to implementing a centralized mixing station in a construction site, which is a concept called just-in-time delivery as one of the lean principles. So in the traditional management and in the conventional construction projects, generally, the subcontractors, each subcontractor makes his own material separately in the different locations in the construction site, which lead at the end of the day to a lot of waste in the construction site and to surplus material that wasted. So the construction company that I studied in this research decided to make a centralized mixing station in the construction site and not allow the subcontractors to mix the material by their own, but to mix it in a specific location. Then the worker mix in this location can send the material to any location within the construction project using an elevator. So I went to the construction site, met with the people, with the project manager, with the site engineers, with the subcontractors themselves to investigate the impact of centralized mixing station in reducing different types of waste. And actually, the results showed that centralized mixing station resulted in eliminating the non-value adding activities because the different subcontractors don't need to mix the material. The materials will reach them as a mix, so they will devote their time to the value adding activities like to buildings or to tilings. Second, the centralized mixing station keeps the construction site clean and in order, which is an important role in reducing amount of waste of different kind of process. Like they don't need to clean the construction site and deliver all these waste to specific location and then send it to a landfill, because now the things is more controlled in a specific location. Improving the mix properties and characteristics. So a worker mixed in a specific location for all the construction site according to the ratios and the codes will help in standardizing the work, which is a lean tool. improving the mix quality by avoiding mixing different materials with different characteristics in the same location, supporting control and monitoring materials, and one of the most important issues is eliminating material waste. So generally in the traditional way, when each subcontractor mix, they will mix randomly. And at the end of the day, there will be surplus material. And because the subcontractor is not paying money for them, they don't care if this material is wasted. While now, because the mixing is according to just-in-time delivery, so the subcontractor will receive the amount of quantity that only needs for his or for her work. So at the end of the day, there will be no surplus material to be wasted. The second experiment is entitled of Role of Lean and VDC in Reducing Physical and Operational Waste and Improving Environmental Impact. So this experiment aims to answer for the questions. To what extent can Lean and VDC improve masonry block partition walls? Can they reduce the non-value adding activities? How can they reduce the operational waste? How can they reduce the physical waste? And what are the environmental impacts of these different types of waste? So actually, I started this experiment during my master's degree. I studied two construction companies. One of them is used in traditional way, while the other one is implementing lean construction using BIM, virtual design, and construction. And I extended the experiment during my PhD to include a new construction project with different construction method to identify the effect of construction method on generating some kind of process waste. So we can see that the projects studied in 2019, the traditional project, only 1/3 of workers' time activities were value-adding activities, and the rest are non-value-adding activities. When the company implemented like a lean construction and used virtual design and construction to optimize the number of blocks to reduce the cuttings, they quantified the amount of blocks required in each location and send the required quantities at to the right time at the right location. This results in improving the worker value-adding activities significantly to around 68%. Now, the project used Lean and VDC is used gypsum block, while those projects that traditionally they used Eton block. Now, in the new project I studied the effect of the concrete block in terms of value-adding and non-value-adding activities. And the results were very eye-opening. It showed that only 1/4 of workers' time is value-adding activities because they are spending their time on activities within the construction method itself, which is defined as a waste from lean point of view. So this table summarizes the projects studied. The first rows show the value-adding activities in each project, while the other rows shows the non-value-adding activities like cutting, moving blocks, moving between stories, cleaning, mixing, shuttering. Now, after that, I studied the environmental impact for those three different types of blocks with their management approach. So in the traditional project, it's used Eton block. So the global warming potential per partition area built is 25.6 kilogram CO2 equivalent per meter square. While in the traditional project C1, which is used concrete block, it's the global warming potential is 58.4 kilogram CO2 equivalent per meter square. On the other hand, in the Lean and VDC project, the amount is only 12 kilogram CO2 equivalent per meter square. This is due to two things: to the embodied greenhouse gas emissions in the material itself and the reduction in greenhouse gas emissions in the material waste. And if we look also herein, in the amount of the waste percentage, it reduced to only 6% in the Lean and VDC project compared to around 22 and 12% in the other traditional project. So this shows the importance of Lean in reducing both physical and operational waste and improving the environmental performance. The third experiment is to test the role of workflow in reducing life cycle energy consumption in construction. So this experiment aims to answer 5 questions. What is the effect of applying a transformation view approach alone to achieve green buildings while ignoring flow and value views? What is the effect of VDC and last planner system on improving the workflow? What is the effect of improving the construction workflow and reducing the project cycle time in cold climate areas? What is the effect of process and operations optimization in terms of increasing or reducing greenhouse gas emissions? So at the beginning, I created a framework to measure the environmental effects in the 3 dimensions. So this framework shows where all the greenhouse gas emissions sources during the construction phase of the project. So there are aspects related to transformation like material and material waste, which are already covered by completing an LCA model to capture all the greenhouse gas emissions in these sources. While other environmental aspects related to weighting, inspection, rework, construction method, and weather conditions related to flow or not achieving the value, over design, and value delay, those things which has an environmental impacts are missing in the current state, which highlighted and covered by this framework. So in this research, I studied 2 construction projects, each of them consisting of 23 floors with 6 apartments. The 2 projects belonging to the same construction company. One of them started constructed in 2011 before the company started their lean and BIM journey, while the other one constructed in 2018 using lean and VDC management approach. Actually, I collected all the related data from the control department in the company, collecting start and finish dates for each location, and created the line of balance charts. Then I modeled or I simulated these 2 buildings in cold climate areas. So maybe one can ask why I selected cold climate areas. So actually, I worked in 2016 in Kazakhstan, in Astana. And what I saw over there that during the winter time, the temperature declined significantly to 10, 20, and 30 degrees below zero. So you cannot work during the winter time unless you heat the construction site. And in that construction site, there was a lot of, they closed the construction site with some temporary materials like nylons and used a lot of heaters. And these heaters operated 24 hours, like for example, before, after, and during casting the concrete, and not only for the concrete itself, but also for the different kind of finishing activities like HVAC system, mechanical, electrical, even plastering, because if you don't heat, then all these systems will be cracked. So I found that it's a good opportunity to identify the effect of space weighting and crew weighting on generating and increasing the amount of greenhouse gas emissions. I used the cradle to grave greenhouse gas emissions, which include extraction, processing, transport, distribution, and combustion. In 1 liter of diesel is 3.31 kilograms CO2 equivalent. This is from one-click LCA database. Actually, to study the space weighting effects, I have 3 scenarios. The first one is the original, based on the data that I collected from the control department in the company, while the other one is a process optimization, in which tasks from the original schedule were considered to perform as soon as possible to remove all the waiting in location and reducing the project cycle time. Also, I used operations optimizations in which queues were assumed to have continuous work and did not take into consideration the effect of space weighting. So this figure shows us the line of balance for the lean and VDC project, and this is the original one. The project duration is around 330 days. So we can see that there is some weighting. But when we did the process optimization and we assumed the weighting will be 0 after finishing the first activity, then the successor activity will start as soon as possible. This resulted in reducing the project cycle time with around 8 days. While when I assumed the crew optimization to ensure the continuity for the work without taking into consideration the effect of weighting of the location, the project cycle time extended to around 430 days. Now, in the traditional managed project, we can see that the original duration for the project is around 380 days. When I did the process optimization, the project duration reduced to around 280 days, while in the crew optimization, the project duration extended to around 430 days. This is for the overall project duration. And if we look on detail in each floor within the building from floor number 1 to 23, and we look on the average cycle time for each floor, we can see that the original scenario and the process optimization in the lean and VDC managed project is approximately coincide with an average of around 120 days. While in the traditional project, the original scenario and the space optimization is far, and the average cycle time for the location is around 190 days. So when I calculated the amount of diesel that need to heat the traditional project and the amount that needs to heat the lean and VDC project, in the first one, the traditional project, the amount required is around 13,600 liters, contributed to 1,037 tons of CO2 equivalent. While in the lean and VDC project, due to the reduction in the project cycle time, the amount is 8,000 liters, which contributed to 629 tons of CO2 equivalent, a 40% reduction. So this can show the importance of lean and VDC in reducing the project cycle time by around 40%, which contributed to reduce greenhouse gas emissions resulted from burning fuel and diesel. Also, an important thing, we can see that in the lean and VDC project, delta between the original cycle time and the location optimization is 6 days, which means that the general contractor succeeds to manage the subcontractors and achieve global optimization and improve the overall project performance. While in the traditional project, delta between the average cycle time in the original scenario and the location optimization is 88 days, which means that the subcontractors succeed to manage the general contractors and achieve local optimization. Also, from environmental impacts, we can see that there is a reduction by around 400 tons of CO2 equivalent between the two management approach. So this highlights the importance that green building rating systems should be improved to include the process and operational effects, which have their own greenhouse gas emissions, which is not covered in the current state. Now, let me introduce experiment number 4, which is assessment of greenhouse gas emissions generated during the construction phase. So this experiment aims to answer mainly 4 questions. What is the effect of the project overrun from environmental point of view? What are the best ways to overcome the gaps in the current green building rating systems and to include flow and value perspectives? What data are needed to complete a comprehensive environmental evaluation for the construction process? And how can we collect the required data? So actually, in the green building rating system, there are 2 important categories. One of them called travel and transport, and the other one called energy and atmosphere. They are taking care to investigate the impact of these categories during the operational phase and setting some procedures, some policies to reduce the greenhouse gas emissions generated during the operational phase. However, they not taking into consideration the operational phase, which have a lot of workers and a lot of utility during the construction. So from a company called Construct CO2, I collected a data set from over there. So Construct CO2 is a company that it's a consultant firm that collected data from hundreds of construction projects around the UK. I did an analysis of the empirical data that I collected from this company. These data includes management, operatives, visitors, material delivery, waste disposal, site fuel, and utility emissions. Then these data or these categories also were classified into scope 1, 2, and 3. Scope 1 emissions related to direct emissions, which means that any kind of emissions that generated and owned by the company or by the general contractor. While scope 2 and scope 3, which is the indirect emissions, are not controlled or not owned by the general contractor. For example, scope 2 related to electricity purchased from the company or from the government, while scope 3 is any kind of deliveries or any kind of greenhouse gas emission sources that are generated by the subcontractors and not by the general contractor. Now, those are the equations that used to calculate and capture the different kind of greenhouse gas emissions. So for example, if we look on management emissions, so to calculate the amount of greenhouse gas emissions that are generated daily to the construction site, you should capture the number of trips, distance traveled, number of managers or engineers come by the vehicle, and the emission factor per the vehicle per kilometer. The same for the operatives, for the visitors, and for the different kinds of the 7 main parameters. Then, from the data set that I collected, and in order to highlight the missing in the current green building rating system and to develop things that measure the effect of the construction phase, I developed an index called a green index. This green index consists mainly of 7 parameters. Each one has its own average, weighted average, which is calculated based on its importance. This index will help any company to identify the effect of the project on environment during the construction phase. Also, it can give you an indicator to compare the project with other previous projects. So to calculate the indicator, for example, B1 related to management emissions, the equation will be 1 minus amount of greenhouse gas emissions that generated for this construction project over the maximum amount of greenhouse gas emissions generated for this category among the statistical or the sample that collected for the construction project. And to calculate the weight for each of these parameters, the weight is calculated by dividing the maximum category emission to the summation of maximum for each category. So this is an important point, that the index will be dynamic and it will be calibrated and be sufficient for any economy around the world, because it will depend on statistical data from this country or from this economy, and the weight will be calibrated accordingly based on the importance of the greenhouse gas emission sources. So after I developed the index, I applied this index in 3 different construction projects in order to see how is the index behavior. So if we look on the green color show us the ideal values for the 7 parameters with the B total, while the blue color represents the actual B values. And this line represents the average for the all projects. So what I mean by ideal value for B1 0.45 or for B2 3.7, this means that if the project achieves 0 greenhouse gas emissions during the construction phase, it will get 0.45, or it will get 3.7 for parameter B2. However, in this project, which is the best project in our sample, it gets the overall 9. Like it got 0.44 out of 0.45 in B1, or 3.1 over out of 3.7 for B2. While if we look on the worst project, which has the highest amount of greenhouse gas emissions, it got value 0, because this project is the worst in our sample, and the overall is 0.63. And if we look on the embodied and compare the index value related to the amount of CO2 equivalent per meter square, we can see that the first project, which got 9 out of 10, the amount of greenhouse gas emissions is around 40 kilograms CO2 equivalent per meter square. While in the worst project, which got 0.63, the amount of greenhouse gas emissions generated is around 250 kilogram CO2 equivalent per meter square. Now, also from the data that I collected, I developed some correlations to investigate the effect of the project duration on the amount of greenhouse gas emissions generated. So actually, we can see that the longer the project duration, the more greenhouse gas emissions will be. Also, I classified these projects into three things: the traditional project, and the overall project, and the project that managed using lean and VDC. We can see that the slope line in the lean and VDC project is lower than the conventional or the traditional project, which means that the sensitivity for the project duration in the lean and VDC project is lower than the traditional project. Although in both of them, like the company should try to reduce the project duration as much as possible to reduce the amount of greenhouse gas emissions generated. I built the correlation between the duration and the amount of kilogram CO2 equivalent per 1,000 pound spent for scope 1, scope 2, operative emissions, delivery, and scope 3. We can see in some curves, there is some scattering in the data and it has some low standard deviation. Actually, there is a lot of explanations for this. Maybe because at the beginning, when I collected the data from the company, some of the data is missing, and the company that collect the data from the construction projects not collected all the data. Others related to, like when they said we are implementing lean project, they don't say to what extent they are implementing lean. Like lean is is a management approach, and it has a lot of principles and a lot of tools. So they don't classify this exactly, or they don't classify to what extent they are using building information modeling. And so those are explanations for some kind of scattering in the data. Other things related to the data that I collected, I tried to build a correlation to identify the percentage of greenhouse gas emissions related to the 7 categories. Actually, in my data set, I found that around 50% of greenhouse gas emissions related to operative emissions. Maybe this is suitable in the UK or in our country or in like moderate climate areas. But for example, if you go in cold climate areas, and how I showed previously in Kazakhstan, in Astana, heating required a tremendous amount of diesel to heating the construction project. So if, unfortunately, I did not have the opportunity to collect like a holistic data from these cold climate areas and build the correlation, but here the methodology is ready. But over there, I suppose, or I think maybe site fuel emissions will be the dominant. So for this reason, when I created the green index, I said it will be suitable for any economy around the world because it will be calibrated based on a data from this economy, which will give more realistic than a green building rating system, which is only designed for their own country. So as a findings from this experiment, we can see that the longer the project duration, the more environmental hazards impact. This highlights the importance of optimizing the project duration and reducing the project cycle time to minimize environmental impact. This helps construction company and decision makers to take strategic decisions to reduce these greenhouse gas emissions. These decisions could be at two different levels, internally and externally. Internally, by using different management approaches, using construction technology to improve worker activities, to reduce project cycle time, or to use renewable energy sources. Externally, the same things, by contracting with subcontractors whom apply different management approaches or using renewable energy sources. Also, as a conclusion for our for the green index that I developed, the green index is a vital and live tool to benchmark and present the construction project environmental impact. It measures the project's environmental effectiveness at any time instance. It helps the project manager or any third party to monitor the project performance and take decisions to mitigate hazards. One of the most important characteristics that it shows the total value for the green index and for each parameter individually, which help the decision makers to identify the critical parameters that reflect and cause the highest environmental effect, and to invest and take better decisions to reduce the greenhouse gas emissions related to these parameters. The index with its parameters help the companies to benchmark the current project and compare them with other previous projects. This in turn will help companies to measure the marginal impact for implementing different construction management methods in reducing greenhouse gas emissions. So at the end, and as a conclusion for this research, and based on the questions that I generated at the building, and when I said about are the current green building systems adequate, so simply no, the current green building rating system is not sufficient for insufficient for achieving truly green buildings, because they are not covering the construction phase in terms of process and their associated operation. So in what way are the current green building rating systems inadequate? So people look at the transformational part, ignoring the process and associated operation. So they measure the greenhouse gas emissions only on the product and ignoring the process. So they are missing flow aspects and missing value aspects. What is the effect of applying a transformation view approach alone to achieve green buildings while ignoring flow and value? So it only considers the embodied greenhouse gas emissions in the product, but not considering emissions from equipment and tools, site overhead, different kind of utility emissions, durations, oil and gas heated during the construction phase. So what are the differences in emissions resulting from different flows in alternative operations? As we saw on the impact of lean and VDC in reducing project cycle time in cold climate area, I can conclude that process optimization is the best way to reduce greenhouse gas emissions and to avoid delaying the value of the project overrun, because extended project duration will require more resources, and this will contribute to an increase in greenhouse gas emissions generated during the construction phase. What is the effect of the project overrun from environmental point of view? As we saw in the last experiment, the longer the project duration, the more greenhouse gas emissions will be generated. What are the best ways to overcome the gaps in the green building rating system and to include the flow and value? So to include that, flow and value perspectives should be included and integrated into a comprehensive way within any green building rating system. The data needed to complete a comprehensive environmental evaluation for the construction process or is anything that generated greenhouse gas emissions during the construction phase, like management, workers, material delivery, waste delivery, site fuel, and utility emissions. How can we collect the required data? Simply documenting all the previously data in a database to account the greenhouse gas emissions generated during the construction phase will be a good solution. Then using these data for the index that I developed will give you a good indicator of how is your construction project is behaved during the construction phase. So the contribution of this research developed a new framework and method for evaluating greenhouse gas emissions during the construction phase. It introduced knowledge about the process effects of lean construction to operationalize cost-effective green construction methods and optimize green buildings as a product. A method that show how lean can optimize and improve green building is expected to have significant impact on both construction management and environmental decision-making fields and encourage more research in these fields and in these disciplines. It demonstrated a practical tool for any client or third party or contractor to estimate the environmental measure impacts. It will motivate governments, clients, and decision makers to apply this method by demonstrating its importance and benefit. and the proposed method will enable green building at lower cost relative to conventional buildings. Those are some publications in journals or in conferences that already published. And actually now I'm preparing also a literature review paper, and for the last experiment, the Green Index, another manuscript. At the end, I should acknowledge Ministry of Construction and Housing, Technion Graduate School, Technion Sustainability Frontier for funding this research. And I will also thank Professor Sabrina Spatari and Professor Rafael Zaks in supervising and guiding me during my master and my PhD. And thanks very much for your listening and for your attendance. And now it's your question time.
Thank you, Musab. Thanks. I wanted to ask the audience if you have any questions. This is a good time. Raise your hand. Michelle, please.
Okay. Yeah. So I wanted to challenge you a little bit, Musab. First of all, thanks very much. It was a great presentation and great research, really interesting. My challenging question is, how realistic do you think it is to actually implement the measures that you have proposed in terms of policy and in terms of, I guess I would maybe make it a little bit more specific, the question, by asking, what do you think is going to be more a determining factor with regard to actually implementing the more effective measures in terms of reaching the green building goals? Do you think it's going to be policy, in other words, regulation, that's going to require these things, or do you think it's going to be the savings, the cost savings? And
Yeah.
how realistic do you think it is to actually to actually depend on contractors, let's say, to do these more green types of buildings in terms of the transformative or sorry, I forgot the term, but the flow measures?
Yeah. So actually, it's a good answer, and I think it will be maybe based on the stakeholder. Like, for example, if we want to talk about, for example, governments or the clients, maybe both of them, like clients, the cost will be a good incentive, but also like when now I'm seeing around the world, like all governments that they are looking on Vision 2030 and 2050 to reduce greenhouse gas emissions. So they should look on all things regarding or any efforts that need to reduce greenhouse gas emissions. So how I should, like all green building rating systems, look on the operational and on the design phase and not considering the construction phase. Maybe one will say because the operational phase has the highest contribution compared to overall project duration. Actually, but if we still looking on the construction operational phase and ignoring the construction phase, we will reach a time instant and we will find the construction phase is the dominant. So this is the things that I tried in this research to introduce. So the research will motivate both governments and clients to put policies, for example, that maybe, for example, to put carbon taxation like at time instant, and to say you should pay this amount of money if you generate this amount of greenhouse gas emissions. So here, the client and the contractor will push to reduce the greenhouse gas emissions. But also, there are other incentives in terms of cost, because when I introduced the lean management, and in the literature, there is a lot of studies that showed how much lean can reduce the saving and can reduce the material waste. So this will also motivate the contractors to reduce the material waste to achieve dual things, to achieve reduction in the cost, which has economic perspective, and to achieve greenness or reduce greenhouse gas emissions. So I think in the future, to improve the work and to make the things to be more practical, the work should be done on two levels. To start by the contractors to motivate them by showing the economic perspectives. This will encourage them to improve the economic perspective, but in this will improve the environmental point of view and to work on the government level by setting policies, regulations, like in order to control the environment and enabling the environment for that.
Right. So it sounds like it's a question, as I believe I work in policy, as you know. It's a question of educating or acknowledging these types of savings, maybe starting with the stakeholder group of the construction industry. And then that will maybe generate some political will to cause the policymakers to change, to follow suit. Anyway, okay, thank you very much.
Yeah, thanks.
And regulation, if we go to a carbon tax, some regulation.
Right.
Yeah.
Raymond, you have a question?
Yeah.
Yeah, I just I'm wondering, not just with the GHG emission analysis, but like when you're looking at implementing lean principles, how do you, is there another way to measure where you have like a more resource efficiency rather than just GHG emission or cost effectiveness? There can also be other sustainable benefits if you considered that. Maybe like in the construction industry, I know they use a lot of water, like reduce water consumption, things like this. How you could measure that in a less on the economical view, but more on the environmental view. Did you think a little bit about this?
Yeah, actually, it's a good question, Raymond, because there are a lot of matrices or indicators to measure the environmental impact, from an LCA perspective. However, I focused on this research in the greenhouse gas emissions as a one parameter because it's the dominant on the sector, and the greenhouse gas and the construction industry is generating a lot of greenhouse gas emissions. But other indicators like water consumption, acidification potential, or other things could be used as a future indicators.
Thanks.
Any other questions? Okay. I just want to ask one last question and then we'll conclude. So in your research questions, you asked whether current green building rating systems are adequate, and you came to, through all these controlled experiments and simulations, you came to the conclusion that construction processes are largely ignored in current rating systems. So then you developed the Green Index. And the Green Index, it was nice. It followed the protocol of emissions, and it's a dynamic tool that can look at different construction projects in any region. So my question to you, Musab, is how do you think the construction industry can adopt this index? Should it be part of green rating systems? How do you see it, its like success of implementation?
Yeah, actually, it's a good question. So this is maybe like I suggested as a future work, like the green building rating system, are how I showed that they don't cover the construction phase, and they don't have any kind of categories or points. So the green index will be a live and vital tool to show how much your construction phase or the construction phase for your project like emission the greenhouse gases. So I think it should be integrated within any green building rating system by its own as a category for the cold climate, as a category for the construction phase, like to add a category on the construction phase in any green building rating system, and to say that here is the index that used to apply. And I think after that, it will be a good tool because how I showed that the weighted average for each indicator is calculated based on the economy or based on the region, which give it the dynamicity that it's missed in the green building rating system. For example, LEED is designed in the United States, but if you want to apply it here, you will find sometimes that things are not suitable for our country. But in this green index, since it's only parameters and each one is calibrated dynamically accordingly, so it will be suitable and flexible to be adapted in any green building rating system.
But then I would ask Musab, do you have a sense of what proportion the process consideration should be of an overall index? For example, if we're going to be integrated in LEED is a point-based system.
Yeah.
Let's just assume for a moment that there are 100 possible points. How many points would you allocate to the process issues that you've identified out of the 100?
Yeah, actually, it's a good question. Maybe herein, like when I said I should integrate it within a green building rating system, like not to be integrated within the points itself. Because actually, like I tried to find a lot of studies and on the literature to see how much the construction phase belonging to the overall from the design, construction, operation. And actually, there is nothing fixed or approximate because each construction project has its own material, has its own operational phase. So the percentages are vary. For this reason, also, it's difficult now to say, for example, I will give the construction phase 10 points like for this green index and integrate it within a green building rating system, because at any time in instant, maybe we will reach to zero greenhouse gas emissions building and the construction phase will be the dominant. For this reason, I suggest this to be a standalone, but to be integrated within the green building rating system to assess the project. Like, for example, to say that this project achieves 90 out of 10 for LEED points and achieve 7 out of 10, for example, based on the green index related to the construction phase.
Okay.
Good. All right.
Yeah.
Thank you so much, Musab.
Yeah, again, thanks for
Nice
the
seminar
attendance.
and really great questions. So, yeah, we'll see you soon at the final defense.
Yeah.
And perhaps a
Yeah,
last round
thanks.
of applause.
Thanks very much.
Okay.
Yeah. Thanks very much, Michelle, and for all the others for the attendance and for your
Yeah.
time. Yeah.
Great
Bye.
timing on the lecture.
Yeah. Thank you.
Thank you, Musab. Good luck.
Yeah. Thanks, everyone.